Hello everyone, this is Giuseppe Sec, and in this video we're going to be going over static analysis of binaries from an IoT device. In a previous video we went over how to get a shell on a device using the UART interface, and you can see we're kind of picking up from there. We currently have a shell on the TP-Link Tapo C210. This is just a IP camera. I'll leave a link in the description for the previous video if you want to follow along and get a shell on your own device. But what we're going to be doing from here is following this blog by this Hacefresko guy, where he finds an unauthenticated command injection vulnerability in a previous model of Tapo IP camera. I'll leave a link in the description for this blog post as well. Just a brief summary, he finds that there's an HTTPS server running on 443, the purpose of this server being to communicate between the camera and a mobile device, whether that be Android or iPhone, the app that's supposed to control the Topo camera remotely. And after getting a shell on the device using the UART interface, he is able to determine that it is that the server is UHTTPD. This is the default server that is used by OpenWRT. So basically, all cameras, all the Topo cameras are using a fork of OpenWRT, which is just an open source router operating system. So what he does from there, so he gets the binary for the server off the device, he puts it in Ghidra, and he ends up finding a function that is using the popen function. And you can see that the argument that the popen is using is being passed into the function as well, which gives it the appearance of it being a dynamically used like variable or argument. And if you're unaware, popen is, let's see, a function that opens a process by creating a pipe, forking, and invoking the shell. So basically, in this case, it's executing a shell command. And in cases where the argument that's being passed to popen is dynamic, if that dynamic argument is taking any sort of user input, and the user input isn't properly sanitized, that can potentially lead to command injection. In this case, what's going on, he finds out that what's going on is that there's a JSON payload that is being sent in a post request to set the language of the mobile app. And this is specifically the payload that contains the command injection vulnerability. And it turns out that one of the values being passed in the payload, in the JSON payload, is actually the argument that's being passed to the popen function. And yeah, to give you a quick demonstration of that, we're talking about JSON. So let's just say there's like a key here, and then the value, it's like, say it's like the bash command, the Linux command, who am I? Because there's the lack of sanitization in there, in the payload, what he ends up finding is that he can add a quote that can basically close this first portion here, and then he adds the semicolon to run a simultaneous command. From there, he's able to, add an additional command there and get command injection. And you can think about it kind of like doing something like this, right? Like if we were just to run who am I, we would just get the output from there. If we were to run ID, we would get that output. But if we're running it simultaneously using the semicolon, yeah, in this case, he's able to get command injection. Anyway, with that out of the way, let's see if on this newer model we can find the same vulnerability. And we can already confirm that there is an HTTPS server on this model by running netstat. These flags, the T flag is going to specify processes that are have a TCP port open. The L is going to specify for listening ports. The P is going to show us the process ID that is opening that port, that's listening on that port. And the N is going to make it so that there's no DNS resolution, so we will only see the IP addresses that are being resolved rather than the host names. Let me resize that window because that's a pretty wide output. And that's still... There we go. On 443, we can see we got UHTTPD. So if we want to find out where that binary is so that we can get it off the device, we can just use the which command and specify UHTTPD. And there's the file location. So let's just cd into there really quick. And there it is. So what we can do from here to get the binary off the device, well, usually if I have access to the firmware, I could just extract the file system from the firmware using binwalk and get the binary that way. But in this case, I do have the firmware, but none of the binaries in this directory in the extracted file system actually exist. So what I think is happening is that when the firmware is installed, these binaries are downloaded, or maybe they're being hosted on like a separate drive that's then being mapped to user SBIN. Not entirely sure. Point is we can't just get it from the firmware. So what we can try to do is see if we can get it off the device just using netcat. We can check to see if netcat is on the device, and it is. The nc command is our output here. Netcat, it's like the Swiss Army knife of like TCP, UDP protocols, and just makes it so that you can, test connections and whatnot. So what we're going to be doing is on the host, on my host, I'm going to set up a netcat listener, something like that. The L is going to specify that we are listening. The V is going to give us verbose output. N, just like with netstat, is going to show us the IPs rather than the host names. And P is where we're specifying the port. So we're going to be listening on port 9001. And this angle bracket is going to feed all the bytes that our listener receives into this empty file that we are creating, UHTTPD. So when we run this, this angle bracket is going to make it so that we are creating an empty file called UHTTPD, and that any bytes that our listener receives will then get fed into that file. So there we go. What was my IP address? There we go. And then on the camera, what we're going to do is we're going to use netcat to connect to our IP address to our listener, and then we're going to use the angle bracket in the opposite direction, because what we're going to do is feed the bytes from the UHTTPD binary that is in the current directory we are in, so that when we make the connection to our listener, it's like sending the bytes over. We're basically just copying it over TCP. And there we go. So now you can see we have a file called UHTTPD. If we run file on it, we can get a little bit more information on it. We can see it's a 32-bit ARM binary. Yeah, that's how we can get it off the device just using netcat. From here, I'm just gonna open up Ghidra. You can see I've already imported the binary, so we can just double-click that to open up the code browser. And let's see, let's resize a little bit. And my tiling manager is acting up. There we go. Let me see if we can resize this a little bit. And if you are unfamiliar with Ghidra, what's going on here is in this pane, we've got the assembly that is being read from the decompiled binary. It's no instructions at this point. Here's a couple of instructions. There we go. And then in this panel, what's happening is if we were to basically if we are able to find a function somewhere in the assembly, it's going to translate that into pseudo C code. And Ghidra's not perfect about this, but it gives you an idea of what the assembly code would look like if it were in C code, and it just gives you makes it easier for you to read if you can read C. So a good place to start from here with Ghidra is in the symbols tree, the functions directory here. We can see some of the functions that were read from the binary, and a good function to start with would be the main function. This is the entry point of the program. This is all these other functions aren't going to be run unless they're being called in the main function or called by function other functions that are being called in the main function. So just to give you an idea of the execution flow, like when something is initiated and when something finishes, or what the conditions are for something to be started, the main function is generally where you're going to want to start. But sometimes there may not even be a main function in your program. So in cases like that, you can look for the underscore start function. And this is the actual starting point, like entry point of the program. It's what initializes the program's runtime. So it gives you an idea of where else you could potentially look. In our case, though, we don't need to worry about either of these functions. We already know that what we're looking for is popen. So what we can do is we can go to search, go to program text, and we are going to look for the popen, and we're going to use like opening parentheses for more specificity for our search term. We'll click all fields and search all. And already we're getting some output. Get this a little bit bigger. Okay. So it's found 4 instances of it, but the only one that we should be worrying about is the one that actually has a function name in the namespace. If it says external, we're not going to really worry about that. So let's just check this one out. And this already looks fairly similar to the function here in the blog. It looks like he's just renamed this function to exec and read JSON. And that just makes it easier to like follow the flow. So yeah, what we can do now is we can right click this function and find where it is being referenced. Looks like there's 3 places where it's being referenced. Okay, it looks like it's actually getting referenced twice in this SLP proto request. And this function specifically sticks out to me because set language, we mentioned before that the vulnerability was found in the JSON payload that was meant to be setting the language of the mobile app. So let's just follow this function, find where it is referenced. And it looks like we're being taken back to the SLP proto request function. So I'm just gonna go back and rename this to set language for more specificity. And then we'll, yeah, let's just go back here. There we go. So if we scroll down a little bit more in the blog, this looks comparable to where we're at here. It's a little little bit of a tight squeeze. I'm assuming that this function is a string compare because that's generally where it's going to be happening. And then there's a scan AP list as well. So it's not entirely the same, but it looks like what's happening is that there's been some sort of check that's been put in place to try and mitigate the vulnerability here, because you can see the set language function is being called, which then leads to the popen function. And in this case, there doesn't seem to be any sort of check, aside from just checking that if var2 equals 0. So in this case, we can see if var6, and I'm assuming that this is essentially the same thing that's going on here. If var6 equals 0, then we jump in to this JSON, like PC var10 is being set to this JSON object get string origin function. And then basically we get to this other condition that says if PC var10 does not equal, and this resolves to just 0, it's just Ghidra being weird, I believe. So if PC var10 does not equal 0 and PC var10 equals, and then it's using a stir_cur function, and what stir_cur is doing, it is checking for any occurrences of the second argument in the first argument. So if PC var10 contains this hex value, and by the way, this hex value is a single quote. This is the hexadecimal value for like a single quotation mark. So if PC var10 does not equal 0 and PC var10 contains a single quote, and then it's setting PC var10 to 0. So it's nulling it out if these two conditions are met. That to me seems like a pretty obvious attempt to try to mitigate the vulnerability we were talking about, because like we were mentioning before, there was the key, there was the command, and the vulnerability was that he was able to get something like that, and then get his command in there. So basically, we have something that says if there's that one single quote in there, we're going to null the whole thing out. And we can actually confirm that this is what the payload looked like, because if we check the GitHub, we can see this right here was the actual payload that was meant to be setting the language, right? And this was the actual key to that contained the payload that was vulnerable, that was then being passed to the popen. And you can see he's initiating like the command injection with that single quote and then the semicolon. And then there's like the variable that he's passing in his reverse shell. It's just like a typical make nod netcat reverse shell. So yeah, I'll leave a link to this as well. It's already linked in the blog anyway, but yeah, if you're interested. But yeah, that's how the devs were able to mitigate this one vulnerability, this being CVE 2021-4045 for anyone who's interested. But yeah, I hope that was interesting, and oh, the camera seems to be acting up. Anyway, hope you guys enjoyed.